All right, for today's lesson, we're going to need page 215, okay? That is page 215, page 215. So lesson 9, session 4 starts off with a problem about this scuba diver. It says, a scuba diver dives to 180 feet below sea level. The linear equation, negative 60x plus 2y equals negative 360, represents the scuba diver's trip back to the surface. The variable y is their elevation in the feet relative to sea level after x minutes, and they want you to graph this equation. So before we graph this equation, there's a couple things we can do. There's a couple different methods that we can graph this line. First off, we can make an xy table. So if we come down here to this space that we have below, we can go ahead and just make an xy table. And we can set this up with maybe like 4 values. Okay, so x we see in this case is our minutes, so that's our time. And I always start off with 0 if I can, because 0 is an easy number to plug into any equation. So my work, if I'm going to use 0 to plug into the equation, would be negative 60x. That's multiplying, so times 0 plus 2y equals negative 360. Okay, so then if I work this out, negative 60 times 0 cancels out. You got 2y equals negative 360. If we divide that by 2, then y is going to be equal to negative 180. So when I plug into 0, I get negative 180. And that should make sense because at 0 time, that scuba diver is 180 feet below. So below is represented by the negative sea level. So 180 feet below sea level. Okay, so let's say after 1 minute, where would that diver be? So I would go ahead, set it up again, negative 60. Instead of multiplying by 0 now, I multiply by 1 plus 2y equals negative 360. Okay, so negative 60 times 1 is negative 60 plus 2y is equal to negative 360. Okay, so I'm going to go ahead and add 60 here. Cancels. So you get 2y is equal to negative 300. Last step, I'd want to divide by 2. And I would get an answer of y is equal to negative 150. So after 1 minute, the scuba diver is now at negative 150 feet. Okay, let's try one more together. 2 minutes. So at 2 minutes, I'm going to go ahead and set it up again. Negative 60 times 2 this time, plus 2y equals negative 360. Okay, negative 60 multiplied by 2 is negative 120. And then I rewrite the rest of the equation. I'm going to add 120 to both sides. So this will cancel. So you get 2y is equal to negative 240. Last step, I don't want to divide everything by 2. And then y will be equal to negative 120. Okay, so after 2 minutes, we get negative 120. Okay, you guys go ahead and solve for 3 minutes. All right, hopefully you got the correct answer of negative 90. Okay, so then we got some good values there. We could graph with that. Another method that we can do is converting this equation to what we call slope-intercept form. So remember, slope-intercept form is y equals mx plus b. So y equals mx plus b, which means you have to get the y all alone. Okay, for me to do that, if I rewrite the equation, I'm going to come down below. Negative 60x plus 2y equals negative 360. So my first step to get the y alone would be to move the x to the other side. So I'm going to do the opposite. So plus 60x come over here, do plus 60x. That cancels, so you get 2y is equal to, and put your x in front, 60x minus 360. Okay, I don't want to know what 2y's are equal to. I just want 1, so I'm going to divide everything by 2. This cancels, so you get y is equal. 60 over 2 is equal to 30x, and negative 360 over 2 is equal to negative 180. So this is our equation in slope-intercept form. Okay, for me to go graph now, I'm going to go ahead and use a portion of the coordinate grid. Meaning I'm really only going to focus on like one quadrant. And that would be our positive time, but our negative c values here because you're below sea level. Okay, and if I'm looking at these numbers that we're talking about, my x's, I can space those out, 0, 1, 2, 3. So maybe I'll just label every other box. Because this would be 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, but my sea level, these are pretty big numbers, so I need to scale that appropriately. And if I'm looking at these numbers, I see what number kind of goes into all of these evenly. 10s go into that. But another number that's bigger than that would be 30. And I think 30 would be a more appropriate scale for this one. Because if I'm doing 10s, I'd have to get 18 squares down for this one. Okay, so 0, and then the first box would be negative 30. Okay, but I'm going to label every other box. So here we're going to have negative 60, negative 90, negative 120. Again, I'm just counting by 30s. So negative 150, negative 180, negative 210, negative 240. Okay, if I was to plot those points, at 0, negative 180. So I'm going to go 0, negative 180 right here. Okay, if I look at the equation that we just solved, y equals 30x minus 180, I see this negative 180 is represented right here on the graph. That negative 180 is your y-intercept, meaning that's where the point touches the y-axis. Okay, your slope is positive, and it's technically 30 over 1. And every box going up is 30. So up 30 over 1. And I'm going to repeat up 30 over 1. I'm going to repeat up 30 over 1. If I go look at the table of values, 1 is at negative 150, so that matches up. 2 is at negative 120. 3 is at negative 90. So I've got 4 points there. That's enough to make my line. So we're going to use our straight edge, and we're going to draw a nice line there. We're going to extend it past both axes, and don't forget we have to put arrows on the ends. All right, let's go ahead and turn the page. So this back page here on page 216 is just explaining basically everything we did together. So we're going to go to 217. Okay, number 217. Number 1, look at the model. How does writing an equation in slope-intercept form help you graph it? Well, that's when we changed it to our y equals mx plus b, and we solved y equals, that should be a positive 30x minus 180. Okay, so my equation, when I wrote it in slope-intercept form, it identified what our slope-intercept was, our slope and our y-intercept. So this is our slope. This was our y-intercept. So how does the writing equation help? We could say I'm running out of pen there. It identifies the y-intercept and the slope. Then we could also say it makes it easier to graph. Okay, number 2. Look at the line, or solve it. To find a point on the line, you can substitute any value for one variable and solve for the other. Why might you choose to substitute 0 for a variable? All right, you guys go ahead and answer that one. Number 3, what part of the graph represents the situation? And how does slope-intercept form help you understand the problem better? So when we look at the graph there, we could tell the diver starts at negative 180 feet. All right, that was in slope-intercept form, y equals 30x minus 180. So that negative 180, that's our starting point. Okay, so that's easy to tell. We could also tell the diver goes up 30 feet per minute. Okay, number 4, describe 2 ways you can graph a linear equation if it's not given in slope-intercept form. So we did one way. We could make a table of values. Okay, and that was our XY table that we made. We can also convert the equation to slope-intercept form. All right, so we can make a table of values, but we can also convert the equation to slope-intercept form and graph it that way. All right, let's say I had an equation y equals 20x minus 200, and I was dealing with the scuba diver. So the scuba diver, but this was the equation y equals 20x minus 200. Question 1. What would the slope be? Number 2, what would be the y-intercept? Okay, that is it.